So I'll be talking about RTC first. This is the RTC initialization code. So first, this enables the RTC, and next these two resets and turns off reset. And then we must unlock the registers. This is unlocking lock register, unlocking the status, control and interrupt. So next, we need to turn off the time counter and turn off the interrupt so that we can set a 1 to the time second register and time alarm register. Doing this will clear the time invalid flag, and then we can enable the oscillator and the interrupt. So this is how the RTC is now. The time is set to this value, 1 hour 59 minutes and 48 seconds. So now I'll let the clock run and we'll observe how the rollover happens. Now as you can see, as it reaches 60, minute increase, and then as the minute goes over 59, which is 60, the hours increase also, which means the time is working as planned. Okay, now to set the time, we can use the 5-way switch to control. So pushing it to the left allows us to move the selector to the left. Pushing it to the right allows the selector to go to the right. Pushing it up allows you to increment the value at the selector. Pushing it down allows you to decrement the value in the selector as seen. So now I'll set the time to 56 seconds, and now to set the date, same controls as just now. So our first test is to make sure that when during the end of the day, the month will change to 1st of January 2018. Okay, as you can see, it does increase. So for month with 31 days, it is working.
Okay, so now we're doing the test for months with 30 days. We choose April because April have 30 days. Okay, so this is April 30th, 2018. When I run the clock, the date will change to May 1 if the program is working correctly. Okay, let's observe. Yes, the date changed to May 1st.
Now, to test for leap year, my time is set to 235941. And 2004 is a leap year, so when it reaches the end of the day, this should go to 1st of March. So now I let the clock run. As you can see, the time indeed turned to 1st of March, which means the leap year algorithm works. Now to test for non-leap year, I need to set the year to a non-leap year, which is 2005. So now I'll let the time run and we'll see how it goes.
As we can see, after it reaches the end of the day, it rolls over to 1st of March from 28th of February, which means it is not a leap year.
So now to set the alarm, we need to press the center switch to the alarm section. Now, I'll set the alarm to 40 seconds. So currently it's 34 seconds. So we'll see how it goes. So as you can see, as the alarm reached, the alarm indeed sounded. So if I want to stop the alarm midway, I just have to press it. Now the alarm is stopped. The music is generated by using two FTMs, FTM0 and FTM1. FTM0 is set to time overflow mode and FTM1 is set to output compare. So this is the initialization. And this is the entire music. A6 is the note of the song and 9 is the tempo. So this is the whole song. And this is the interrupt request handler for FTM1, which is responsible for the note. So what it does is, for first half of the cycle, it will take the note, and then after that, it will still take the note until it will keep playing the note until the tempo is finished, which is from FTM0 handler, tempo minus minus. So when it plays one of these play note, which is here, so first the FTM clocks will be turned on and it will check whether the center button is pressed. If no, then the global variable note and tempo is set to the one passed into it, which is these two. Okay, so after setting the variable, it will continue. It will have a while loop which makes sure the tempo reaches 0, which is the countdown. After that, the FTM clock will be turned off, and then it continues on until the song finishes. So most of the time, the controller will be running the clock until you go into configuration mode, which is by pressing the center button. This is in configuration mode. As you can see, the cursor is here, but once I go into the running mode, it will just keep running until you do something to it. This is how we set the system frequency, which is 48 MHz, is by calling this function initialize clock, and it will run its algorithm to make sure the clock is indeed 48 MHz. So all I need to do is, in my main function, just call it. So the way the system frequency affects the FTM module is that the calculation of the notes needs to take into account that it is 48 MHz, and for the tempo, we need to make sure we calculate based on 48 MHz too. As for the RTC module, the system frequency does not affect it because for RTC, it has its own frequency, which is 32 kHz based on the datasheet.